Bright Tuty. Every student matters.
Hello students, let's continue the chapter cube and cube roots. So till now we have done how to find whether a number is a perfect cube or not, and we have calculated which number to be multiplied and divided so that we make a number a perfect cube. Now the turn comes for cube roots. So today we'll learn about cube root, what is a cube root, what is its representation, how to find cube root of any number. So we have two methods to find out cube roots. Let's start. So what are cube roots? Now suppose I say 2 into 2 into 2, that is 2 to the power 3 is 8. So we say cube of 2 is 8. Right? Now the things come for cube root. So we say cube root of 8 is 2. Taking the cube root of any cube is inverse procedure of cube. Now what is the representation of it? The representation is this sign. We write 3 here. Right, so this is the symbol that we are going to use for cube root. And suppose I have to write cube root of 8, I'll write 8 inside. It will be equal to 2, because in the cube root of that number will only come once, okay, and in cube of it will come 3 times. So in cube root of 8, 2 will come only once, and in cube of 8, that is 2 cube, it will come 3 times. So this is what a cube root is. Inverse operation or inverse procedure to find of the number, right, of finding a cube. So what we are going to do, we'll do certain examples to know how does it work, right. Let's start with one of the example, that is 3375. Okay, so what we will do, we'll use prime factorization to find this. So what we will do, 3375, if I write, this is one of the number, let us say, and let's do the prime factorization. Okay, so we're going to start with 3. 3 ones are 3, 3 ones are 3, 3 twos are 6, 3 fives are 15. Now again with 3, can we try? Just see, 3 threes are 9, 2 will be left, 3 sevens are 21, 1 will be left, 3 fives are 25, 3 fives are 15. Now again with 3 we can go, 3 ones are 3, 3 twos are 6, 3 fives are 15. Now again 5, 5 twos are 10, 5 fives are 25, with 5 again, 5 fives are 25. Prime factorization, now we have practiced a lot, right? So 3375 can be written as 3 times 3 and 3 times 5. Right? Now 3375 is a perfect cube because triplets are formed. Now it is a cube of which number? Just see, 3 cube into 5 cube. It is a cube of 15. But what we are going to find? We are going to find cube root. So we will write the symbol cube root of 3375 is equal to, now you don't have to take 3 times and 5 3 times. You just have to take 3 one time and 5 one time, and the answer is 15. So the cube root of 3375 is 15. It is the inverse operation of cube. Is that clear? So in the square root, what we were doing is we were not taking it 2 times, we were taking it 1 time. Here we will not take it 3 times, we will just take it 1 time because it is a cube root. Right? Because in the cube of that number, that prime factor will come 3 times, but in cube root of that, it will just come once. Clear? So this is how we find cube root through prime factorization method. Now, here is one question. Find the cube root of 8000. So if we start with 8000, do the prime factorization of it. Just see, 2 fours are 8, 0, 0, 0. Then again 2 twos are 4. Then again 2 we get 1000. Again 2 we get 500. Again 2 if we do, we get 250. Then again we will do with 2, 2 ones are 2 twos are 4, 2 fives are 10. Now with 5, 5 twos are 10, 5 fives are then 5 5s are 25, 5 1s are 5, right? So this is the prime factorization of this number. So 8000 can be expressed as, how many 2's we have? 1 2 3 4 5 6 and 3 5's. So 1 2 3 4 5 6 and 5 cross 5 cross 5. Let's form the triplet. Yes, 3 triplets are formed. It is a perfect cube, and 8000 can be written as 2 to the power 3, 2 to the power 3 into 5 to the power 3. Now we will just not take the powers, we'll just take the prime factors, and we will write cube root of 8000 is equal to 2 cross 2 cross 5, that is 2 2s are 4, 4 5s are 20. Is that clear? So this is how we find cube root using prime factorization method. Let's move ahead now. Here also we have to find out cube root of this number by prime factorization method. Let us start doing the prime factors of 13,824. So starting it, dividing with 2, we get, so by dividing it with 2, we get 2 6s are 12, 2 9s are 18, 2 1s are 2, 2 2s are 4. Again with 2, 2 3s are 6, 2 4s are 8, then 2 5s are 10, 2 6s are 12. Let's do with again 2, 2 1s are 2, 2 7s are 14, 2 2s are 4, 2 8s are 16. Again with 2, 2 6s are 18, 2 6s are 12, so we should write 2 8s are 16, right? 2 8s are 16, 1 is left, 2 6s are 12 and 2 4s are 8. Again with 2, 2 4s are 8, 2 3s are 6, 2 2s are 4. Again with 2, 2 1s are 2 2s are 4, 2 1s are 2, 2 6s are 12. Again with 2, 2 1s are 2, 1 is not divisible, so we'll take a 0, and 2 8s are 16. Then 2 5s are 10 and 2 4s are 8. Again with 2, 2 2s are 4, 2 7s are 14. So we get 27. Let's divide 27 here. So with 27 we will get 3, 3 9s are 27, 3 3s are 9, 3 1. So we can write 13,824 can be written as, how many times 2 do we have? 1 2 3 4 5 6 7 8 9 times. So let us write that 1 2 3 4 5 6 7 8 9. And how many times do we have 3? 3 times. 3 cross 3 cross 3. Form the triplets. This is the first, a group of 3, again group of 3, this is next group of 3, and this is another group of 3. So yes, it can be written as 2 to the power 3, 2 to the power 3, 2 to the power 3 and 3 to the power 3. And here we have 13,824, right? So now we will write cube root of 13,824 will be equal to 2 cross 2 cross 2 cross 3. Just take the numbers once. Okay, these 4. 2 2s are 4, 4 2s are 8, 8 3s are 24. Right? So cube root of this number is 24. So doing the prime factorization method helps you find the cube root of any number. Clear? Here is one question, a very interesting thing. So they're asking, state true or false for any integer m. So this is actually m square. M square is less than m to the power 3. Why? We know that for any integer we will have m square less than m cube. So what we can write is, just see. So they are saying for any integer, integer can be positive, can be negative. When we talk of here in your class, we are talking of positive numbers. So if I take suppose 2, square of 2 less than square cube of 2. 2 square is 4, 2 cube is 8. So yes, it is less than it. It is true for all the positive integers, right? So this is how we do it. Now in case we try, just to see any other number, let us try with 6. Okay, and take another 6 is the number, so 6 square less than 6 cube, Definitely it will be less than, because in square it is 6 into 6 and in cube we have 6 into 6 into 6. It is multiplied 3 times. So definitely it is going to be more in case of positive integers, right? What about negative integers if we think of? Just to see, if I take minus 2, okay, so minus 2 whole square and minus 2 whole cube. In square this number will get positive and it will be minus 8, but 4 is not less than minus 8, it is greater than this, right? So if we talk of only positive integer, this will be a true statement, but if we take case of positive as well as negative integers, this is not true for all, it is true only for positive integers. So here it is not mentioned that these are positive or negative. So for any integer, if they are asking m square is less than m cube, so yes, the statement is false. Clear? Let's move ahead now. Now cube root of a cube number. So what we are going to do, we are going to find out cube root of a cube number. How we are going to find out? Using the estimation. Okay, so what we are going to do, this is a simple question, like I say, a simple method of finding out, but this is not used everywhere. What we are going to do, we are going to use it in some of the cases where it is mentioned that we have to find the cube root using a particular estimation method. Okay, otherwise we have prime factorization for finding out the cube root. Okay, so let's take the example of the number 857375. Okay, suppose this is the number and I have to find out cube root of it using the estimation method, we say. Okay, so what we are going to do, because we have 6 digits, we'll make group of 3. Every time we will make of group of 3 digits starting from the rightmost side. So 375 is there, we will make a group like this, okay, and 857 is there, another group. So if suppose we had 5 digits, suppose we have like this, so 3 digits and the second group will be of 2 digits only, right? So right now we are considering this one. So now these are 2 groups, okay, this is one group, this is another group. So what is 5? Here is the last digit as 5. So first step that we are going to, first of all, can you see how many groups are made? There are 2 groups made. So we will have 2 digits in the answer, in the cube root. Now the last digit is 5 here, okay. So in the cube root of it, the last digit will be, what is cube of 5? Cube of 5 into 5 into 5 is 125, so 5 only. So we know unit digit, okay, unit digit in the cube root is, see, cube of 5 will be 125, so this you write down in bracket is 5, right? Noticing this, we can just have a circle on it and make you notice that unit digit in the cube root of this number will be 5, right? What about this second number, that is 857? So what we are going to do, we are going to think of the numbers, right, whose, so we observe that the second group is 857, okay, this was our first group, and second group is 857. So you have to think of a number whose cube is approximately equal to 857. So let us try it. 8 cube will be 512, 9 cube, okay, 9 cube is 729 and cube of 10 is 1000. And we see that 857 lies between these two numbers. So we know that 825 is more than 857 is more than 729 and less than 1000. Clear? So it lies between these two numbers. That means it lies between the cube of 9 and cube of 10. So we take the smaller number. So tens digit. Our tens digit will be 9. So we got ones digit as 5 and tens digit as 9. So what is the cube root of this number? It is 95. I am again repeating what I have done. Whatever number you have, try to make group of 3 digits starting from the last number, that is 5. Here. Now you get 2 groups here. First is 375, second is 857. Now in this, the unit digit in the cube root will be given by the first group, right? First group has the last digit as 5. You know, when the cube root has a digit 5, when it ends with 5, so unit digit in the cube root will be 5. Okay, now the second part, that is second group 857, will give us our tens digit. So we have to think of the numbers whose cubes are near about 857. So we have found here two numbers, that is 9 and 10. 9 cube is 729, 10 cube is 1000, and they are lying near about 857. That means 857 is more than cube of 9 but less than cube of 10. So we take the lesser number. Okay, that means 9 cube we are going to take, 9 we will take. 9 will form the tens digit. So the cube root of this number is 95. Without doing the prime factorization, we are able to find it. Let's try to find out one more question based on the same concept. See here, we have to find out 17,576. Right, this is there, and we have to find out its cube root using the estimation method, that means the method that we have discussed now. So we will form two groups, one will be like this and another will be just 17. Is that clear? Now 576 is there, clear? So when does the cube root of any number ends with 6? You know that? You know cube of 6 is 216. So unit digit will be 6. That is given by this first group. Now the second group is 17. We have to think of cubes which are near about this. So we know that cube of 2 is 8 and cube of 3 is 27. So yes, 17 lies between cube of 2 and cube of 3. As I told in the previous question, what we have to do? We have to take the smaller number, that means 2 in this case. So tens digit is 2 here. So what is the square root, that means cube, what is the cube root of this number? It is 26. This is our answer. So this is the method of estimation, that without doing the square, prime factorization method, we can find out the cube root of the numbers. Clear? So this is there. We have learnt finding cube root. First of all, we discussed what is cube root. Then we did the prime factorization method and have done examples for finding out cube root using prime factorization. And now we have discussed a short trick, I would say, to find out cube root, that is finding cube root through estimation.